Hello and welcome everybody. This session we are going to talk about the use of GC in different applications beyond the HPI industry. The typical use that we see of the GC is for the HPI, and for probably very obvious reasons is because the instrumentation is such that it suits the analysis, or vice versa, the types of compounds that we analyze in HPI industry are probably more suited for the GC analysis. So we use GC very often in HPI industry, but we want to see beyond HPI, more than HPI, where else we might be able to use the GC. So in next 30-40 minutes, I will try to make a case where I will try to convince you that the GCs are actually useful even for many different applications more than the HPI. GC in HPI, it's a tradition, and as the title says here, or as the heading says here, that we all like to follow them. Why we use GC in HPI? Well-known subject to all of us. GC is the preferred solution that HPI heavily relies upon. Reasons for this dependency are very obvious. Well-established methods. Most of the analysis that we carry out in HPI industry, we use some kind of reference. That reference actually most of the times guide us to the GC analysis. So the methods are very well established. The types of compounds that we analyze are actually far better suited for the GC analysis. So because the compounds are relatively low molecular weight compounds, they are volatile compounds, and are fortunately stable with the heat, and therefore analysis of these compounds using the GC technique becomes possible. To analyze these many different compounds, there are many different sample introduction techniques that are available. So a typical inlet like a splitless inlet, maybe the multi-mode inlet, the programmable temperature vaporization, the PTV inlet, the cool on-column inlet, which we call a COC inlet. These typical inlets are available. Besides the inlets, what else is available are the typical sampling instrumentation. So the headspace is available for us to do the analysis of VOCs. Similarly, the new technology from PAL called ITEX, which stands for in-tube extraction, is also available now for doing the analysis of VOCs. And the ITEX is very well comparable with the headspace strap, and therefore the sensitivities, if one is looking for a higher sensitivity, much higher than say a typical headspace sensitivity, then ITEX is really useful. Solid phase micro extraction is another way to do the sampling for the VOCs and the SVOC, so that is also available. SPIMI, the manual SPIMI is available, as well as the SPIMI automation is available. Thermal desorption, which is a very widely used technique to do the VOCs analysis in air, is available, and so the HPI requirement actually is fulfilled. Persian trap is once again available if somebody is looking for VOCs analysis in water, in soil, at a very low concentration. So typical inlets are available, and then typical sampling devices are also available, which are very well suited for our HPI industry analysis. Many different columns, capillary columns, as well as the packed columns are available. Now the packed columns are getting replaced more and more with either the capillary column or micro packed column, and therefore we we actually have many different options for the columns. The detectors that are available are actually either very sensitive or they are selective, or they are actually both. They are very sensitive and they are selective at the same time. The flame ionization detector, the thermal conductivity detector, these are absolute backbone of the HPI industry, and we use them very routinely. So FID and TCDs are available. ECD, which is electron capture detector, the flame photometric detector, the pulse flame photometric detector, which is our PFPD, the sulfur chemiluminescence detector, the nitrogen chemiluminescence detector, the nitrogen phosphorus detector, the photoionization detector. These are once again very selective detectors. So the FPD, the PFPD, SCD, NCD are very selective detectors. And then we have the MS and the MSMS. So if someone is looking for that very selective, much more detailed analysis, then MS and MSMS are also available. People use these detectors for the analysis. Once again, the GC is very easy to use. People are really well familiar with the use of GC, and so ease of use is what makes GC really useful in the HPI industry. And then we have the available different automations for the injection. So we have, say for example, the GSV, the gas sampling valve is available. It's automated, gives us very precise volumes that we actually can put on the sample onto the column. Sampling valves. Like GSV, we have the LSV also. So the liquid also allows. Besides that, the liquid auto-samplers are available and they are exceptionally precise, and therefore, when it comes to the relative standard deviation, for say example, the relative standard deviation of area, we actually can really rely upon the modern systems. And therefore, because of all these reasons, multiple detectors, multiple columns, multiple sampling options, very precise GSV or LSV or auto sampler for the liquid injection, GC is really the preferred solution because it makes the day-to-day life of an analyst in the lab really easy, and that's why people have been using the GC in HPI industry for many years now. If we talk about GC in non-HPI, okay, where else GC can be useful? There are many applications that we actually can look at. There are many applications for which we already use the GC. I just want to actually, in some cases, you might find that I'm just giving you the information that you already might know, because these segments that we are going to look at are not really alien segments. We've been using GC in these segments, but I will just give you a little more information as to how the GC is actually really useful, or how the modern GCs are really useful in these different segments. So many applications to look at. Very same reasons why GC is preferred solution in HPI segment. Okay, the same reasons actually are applicable for the non-HPI segment also. So the availability of detectors, the availability of multiple columns, the different sampling techniques that are useful in HPI are also useful in the pharma, the food, the toxicology, and say the environmental analysis like the TPH analysis. Speaking about the pharma, say for example, specifically, we will look at the residual solvents analysis. It's an analysis that many pharma labs will have to do. It's mandatory for many pharma labs, and therefore that analysis actually is very critical, especially if you are looking at the pharma sector. I have seen some people using this analysis, the solvents analysis, in the paint industry as well. So for the paint industry also, the analysis of solvents is critical. Now the solvents that people use in paint industry are a little different than what we use in pharma industry. So the scope is a little bit different, but the overall technology, what we use in the pharma for the residual solvents, the same hardware is still very useful for the paint industry as well. So focusing on the pharma industry, we will talk about the 467, the United States Pharmacopoeia number 467 is what we are going to talk about a little bit. When it comes to food, I will take you through the FAMES analysis and what Agilent can offer when it comes to the food analysis. Toxicology, I'm going to talk a little bit about the blood alcohol analyzer, and you actually might see that the hardware that I'm going to suggest, or we are going to suggest for the pharma, the same hardware is pretty much useful, or the hardware stays the same even for the toxicology, for the blood alcohol analysis, because once again we are going to use the headspace. Once again we are looking at the volatile organic compounds. And then I will take you through the total petroleum hydrocarbon analysis application note, or the information about that analysis. And I will try to convince you that how the new GC from Agilent, which is not really new now, it's Induvo 9000. how that GC actually can really speed up that analysis. And therefore, you will be able to do that analysis in less than, say, 5 minutes. 5 minutes is still quite long runtime, but you will be able to do that analysis even less than 5 minutes. And I will try to make that case in front of you. So let us go one by one through all these different applications. Let me take you through the pharma. Pharma, what we are looking at the USP 467, which is the residual solvents analysis. The typical hardware configuration or the schematics of the configuration is in front of you. You see we have the headspace. Headspace does the sampling part, and what we do in headspace, we actually take the sample in a vial. Now the vial tends to be a little bit bigger. We normally take 20 ml vial. Some labs actually do take the 10 ml vial as well, and both these vials are available with Agilent. So you can do the sampling in the headspace where you take the sample in your 20 ml vial, say for example. So you will add maybe 5 ml of your sample. You will load that sample on your auto sampler. So the auto sampler actually sits here, and all your vials sits here. And then the machine actually will pick up the single vial and will put it into the shaker heater. Now there are multiple options with the headspace. When it comes to Agilent headspace portfolio, we now can offer you 3 different headspaces, one with the 12 vial capacity, the other one with the 48 vials capacity, and the largest capacity headspace is with 111 vials capacity. The temperature ranges for the 48 vial capacity and 111 vial capacity headspace remains the same. So they actually will allow you to go much higher when it comes to the temperature of the oven, the temperature of your transfer line and everything. On the other side, the 12 vial headspace is little lower in headspace. It will not allow you the shaking, but it will allow you to heat your sample up to 200 degrees centigrade. The 48 vial and the 111 vial capacity headspaces will allow you the shaking as well. Shaking is useful because shaking allows you to reach that equilibrium faster, and therefore shaker actually adds the value to the overall headspace proposition. Now what we do, we actually do the sampling here. The sample then is transferred through the heated headspace transfer line to the inlet. In this case, it is a splitless inlet. Then we actually have this deactivated fused silica tubing that ends up in this inert T. And using this T, we are actually splitting the sample in 2 different columns. One is DB Select 624, and the other one is HP Innovax column. Now, some of you already might be doing this analysis, and you might be thinking that why do I need these 2 columns? Because I was doing the analysis using one single column and it worked well for these many years. What is the use of these 2 different columns? I will make that case in the next slide. But we are suggesting that you actually go ahead with the 2 columns 2FID hardware, and then that will give you much better separation. Because why 2 columns are thought of? One column, if you're looking at the class 1, the class 2A, the class 2B standards, no, or the samples to be analyzed, you actually end up doing the analysis for many different solvents. And there is a possibility, and it actually is the practical observation as well, that one single column doesn't do the separation of all the solvents that we need to analyze. And therefore, these 2 columns actually work complementary to each other. If something is not separating on Innovax column, we have made sure that that compound or that pair of compounds separate really well on 624 column and vice versa. So these 2 columns are really complementary to each other, and this is why we suggest you these 2 different columns with 2 FIDs hardware suggestion. You see here we are suggesting you the 8890 GC, which is the latest GC from Agilent. There are 2 GCs, one is 8890 and the other one is 8860. We are suggesting you 8890 because it's the best in the market. That's what we believe at this time. But if one wants to use the 8860 GC for this analysis, he or she can very well use the 8860 series GC as well for this analysis. Going forward, if you see the typical analysis that we do, the class 1 and class 2B standard. I have the example here. So this is the class 1. What you see here is a class 1 mixture. So we are looking at 1,1-dichloroethene. We are looking at 1,1,1-trichloroethane, carbon tetrachloride, benzene, and then we are looking at 1,2-dichloromethane. If we see the area and the retention time relative standard deviation on 624, we actually are very good when it comes to the area relative standard deviation. If we see the retention time relative standard deviation, we are extremely tight when it comes to the retention times. If you see that on the Innovax column, so going from 624 to the Innovax column, if you see the Innovax column, once again, we have very good area relative standard deviations, and these are actually far less than what is allowed in the original USP 467. So we don't really have to worry about the relative standard deviation numbers here for the area. If you see the retention time relative standard deviations, once again, they are once again very tight. And as I was trying to make the case earlier, if we look at the carbon tetrachloride, the carbon tetrachloride on Innovax column actually coelutes with 1,1,1-trichloroethane, whereas this pair of your carbon tetrachloride and 1,1,1-trichloroethane is really well separated on DB624 column. And see, this is where these two are actually complementary columns to each other. So you see, if you are doing the analysis only for class 1 compounds in your USP 467 or as per USP 467, then probably you going ahead with just the DB select 624 ultra inert column is good enough, because that coelution part is taken care with the 624 column. But I'm sure you're not doing the analysis of only class 1 solvents. You probably are looking at the class 2B, you are looking at class 2A, and therefore having those two columns, 2A FIDs hardware is really useful. Now, if we look at the class 2B case, we are actually once again looking at very tight relative standard deviations for the area, extremely tight relative standard deviations for the retention times on the 624 column. If you go from 624 to HP Innovax column, which is a very polar column, we then are looking at these numbers for the relative standard deviation for the area and for the retention time. Excellent numbers, very good separation, and this is how it looks on the two different columns. Now, this is the case for the class 1, where the coelution occurs on the HP Innovax, whereas that coelution does not occur on the 624 column. If I go to 2A case, okay, this is the 2A case, and 2A case or the 2A list is little longer, then you actually will see now there are multiple coelutions. There are multiple coelutions. So if you see, let us take the example of the HP Innovax column and take example of your tetrahydrofuran, the THF solvent. If you see the THF actually coelutes with the methylene chloride or the dichloromethane. So you see it coelutes on HP Innovax. So the THF and dichloromethane coelutes on Innovax, but that same pair separates very well on the 624 column. If you come down into the 624 list and if you see the xylenes actually, the paraxylene coelutes with the metaxylene on the 624 column, whereas that same metaxylene and paraxylene actually they separate very well on the Innovax column. So this is where the columns are actually really complementary to each other, and this is where that two column 2 FIDs hardware is really useful, because now we are able to separate all the required solvents, we are able to report all the required solvents as we need to. And once again, you can see the relative standard deviations for the area and for the retention time. They are excellent. And this is where the strength of the Agilent hardware comes into the picture. So you actually are able to meet the requirements of the USB 467, and then you are able to get all the compounds being properly separated, and then you will be able to report them properly. And this is where the USB 467 is very nicely done using the Agilent GC. So once again, a non-HPI use of the GC for the residual solvents analysis. So this is one case. If you go forward, class 2A is what we just looked at. If you go forward, let us talk about the food analysis and how the GC is useful in the food analysis. Now, for food, there are many different applications when it comes to food. The immediate analysis that everybody gets excited about is the pesticides in food. For that pesticides in food, there are multiple analyzers that are available from Agilent. These analyzers are all either GCMS single quad or GCMS triple quad based. And now, as we are actually going ahead with more and more uh, number wise, many analysis, many pesticides analysis, and we are going down and down and down with the sensitivity requirement. We are actually shifting from the GC single quad to the GC triple quad. And therefore, you would see that now there are very few labs across the globe that really depends upon the GC single quad for the pesticides analysis. Most of the labs have shifted to the GC triple quad analysis. And so the analyzers for the pesticides that are available from the Agilent, there you will find that they are on the GC triple quad mostly. So they are also available. In this case, though, in our today's presentation, I'm going to take only the analysis of FAMES as one case, and then I will try to make a point to you that how the Agilent GC and its workbench solution, its workbench hardware that is available, is useful for the FAMES analysis. So we actually are confident at this time, we as an Agilent team, as an Agilent GBA team, we are absolutely confident at this time that we can give you complete A to Z solution when it comes to doing the analysis of FAMES. So the title here says that it's a complete solution from sample prep to GC analysis to final reporting as you require. What is that we are offering you for the sample prep? We are offering you a unit called Workbench, which is now available with Agilent for some time. This is how the instrument looks like. It is very similar from the top down. If you see, it actually looks very similar to Agilent's tray, the 150 vial tray, because the tower that sits on your GC inlet and then your 150 vials carousel is what we actually have it here, and it looks therefore very similar to 150 vial tray. But it does many more things than the typical 150 vial tray. And now, what all the significant points that it brings to the table? It has got Y workbench, so it has got two syringe modules. So you actually are able to see the front tower here. Behind this front tower, there is a second tower that sits and does the assistance with the sample prep that we have to do. So there are two syringe modules that are available. The 150 vials on the racks. So 150 vials can be placed here on the three different racks. So each rack actually holds 50 vials. And as we have seen in Agilent's 150 vial tray, we actually can pull one single rack or tray out at any time, and then we actually can take it to the table, load our samples, and bring it back to our sample prep unit here, as you see in front of you. Or for some reason you are not able to do something with that samples today, you simply want to store the samples, load the samples, take that tray and then put it, or take that rack and put that rack in the refrigerator. You can then look at those samples tomorrow. So it's very easy. The ease of use is available there. Besides the 150 vials on the racks, what else we have? The Vertex mixer. So the Vertex mixer for the single vial is available on board here, and that actually does the mixing as we require. We can even tell at what speed it needs to rotate so that the vertexing speed also can be managed. The single vial heater is available. That also is available on board, and it just sits at the back of your vials here. The single vial heater can go up to 80 degrees Celsius. So if we have to do a derivatization, say for example, that I take my sample and I have to do the derivatization, say for example, using the BSDFA. So you can actually tell to the workbench that so and so sample, okay, from this so and so sample, transfer so and so sample into this another vial. From this derivatization reagent vial, take say for example 10 macroliter, add it into my sample, do the vertexing, do the heating at say 80 degrees centigrade for say 30 minutes or 40 minutes, and then take that sample and then put it back where from which I then will pick it up, take it to the GC, and then I will do the injection into the GC. So this is also something that is possible. So single vial heater is available. Uh, you actually can heat not only the single vial, but if you have to keep your entire rack of 50 vials hot, that is also possible. And likewise, if you have to keep your entire rack at a lower temperature, that is also possible. So as you can see here, the heating of the entire rack at 80 degrees centigrade is possible, or the heating of the entire rack, the cooling of the entire rack at 5 degrees centigrade is also possible. And on the same platform, you can have one rack at low temperature and one rack at the higher temperature. So actually you can maintain that. That is also possible. And then the software, the machine does the automatic sample tracking. And therefore we know exactly where we are in the sequence, either in the sequence of our sample prep or the sequence of the sample prep. So the machine actually will keep the track of your samples properly. More advantages, the calibration standards also can be prepared because this machine is able to precisely add your amounts of 1 microliter, 2 microliter, 3 microliter, maybe up to say 500 microliters if you need to. And then it will be able to add the required solvents also. You actually can do your serial dilution of your calibration standards on the workbench itself, and then the same set can be used for the calibration as well. The second point, the complete automation of either an acid catalyzed or the base catalyzed FAMES preparation, because we are talking about FAMES here. I have made this point that either you might be doing the acid catalyzed hydrolysis and then derivatization, or you might be doing the base catalyzed hydrolysis followed by the derivatization, and then you might be doing the analysis. So either of those methods, we actually can do the automation. Automation results in more samples being prepared, and therefore we will be able to do more samples on the GC when we are running the sequence. So the automation actually will serve the purpose. It will do the complete automation of your FAMES sample prep. Your sample will be ready here, and then you will be able to take the samples and load these samples directly onto the GC for the further analysis. And you can simply remove the rack here and put this rack as it is on your GC tray if you have that 150 vials tray, and then you can simply start the sequence if you need to. So that is also the advantage. So this is where the workbench is really useful when it comes to doing the sample prep automation. Looking at the chromatogram, and I have taken this specific chromatogram of this animal source FAMES for a very simple reason. It actually talks about the EPA and DHA. These are the omega fatty acids, and many people are actually nowadays interested in omega-3 fatty acids. So these are very typical fatty acids that omega fatty acids that people nowadays are looking at, and its separation sometimes is very critical. So I'm making a case in front of you here. The baseline resolution of EPA, DHA, and other key omega-3 and 6 FAMES are there. The column that we are suggesting you here is a dB fat wax column, and as you can see, it actually is just a 30 meters column. And I actually want to take your attention to this 30 meters column is because typically you might have observed that when we do the FAMES analysis, we tend to use longer columns. Now, longer columns are excellent because they do far better separation, or the separation job is much better, nicely done on those longer columns. But longer columns requires longer run times also. If one wants to reduce the run times, we can use the shorter columns, and therefore this 30-meter column actually still does the excellent separation of the that way critical fatty acids, and we are able to do the analysis much faster. So the fast wax column is available to us. We can use this for the analysis, and then analysis can be done quickly. This is a very nice chart that Agilent has made for us, and as you can see, they are allowing us to select the appropriate column based on the type of fatty acids that we might want to separate. This is the strength of the Agilent. So you see, Agilent actually has got many different columns when it comes to analysis of FAMES. 1, 2, 3, 4, 5, 6. and there is another column that is suggested for the HPLC. So if one needs to do the analysis on HPLC, that is also possible. The example is cholesterol and triglycerides on HPLC. So if you're looking at these typical fatty acids and their analysis needs to be done, we actually have multiple column choices that we can look at. And not only the column choices, but you actually can see that the speed of the analysis also actually can be played with. We actually can look at the speed of the analysis as well. If one wants to do the faster analysis, we have this fast frame column that is available, and that will allow you to do analysis much faster. If one is not worried about the analysis speed as such, the time that it takes for the separation, but if one is very keen about the separation of the cis trans isomers that you might have in your frames, then we have these different column options as well. So a typical HP88, this is a typical column that I myself have used many times, and we have 60 meter or 100 meters column when it comes to HP88, and they do excellent job of the separation, but it takes little longer for the analysis to be over. So depending upon the fatty acid types, we have the different types of column that we can look at. If one wants to do even little different type of say analysis, or one wants to look at the analysis bit differently, we actually have this option also. We can look at the analysis with the type of food as well. So as you can see, the dietary products, the fish oil, the animal fat, if one wants to select the column not based on the fatty acid type, but one wants to select the food, one wants to select the column based on the food type, that also Agilent actually gives you the suggestions. And then once again, the fast frame, as the name suggests, is the column that is really useful for the fast analysis of the fatty acid methyl esters. The slower columns, once again, the select frame or the CP cell 88 or HP88 are going to be little slower columns. But the advantage is that you actually will have the HP88, say for example, at 100 meters, and it will allow you to do a much better separation of whatever that you want to separate. So this is the case for the FAMES. So for the FAMES analysis, we actually can suggest you the sample prep automation. We can then deliver the most advanced, probably the GC that is available in the market. We can give you the 8890 series GC. Not only the GC, but there are multiple column choices that we have that we can play with, and therefore, depending upon the type of either fatty acid or type of the food that you want to look at, you actually can choose the columns. The next analysis that we want to look at, the toxicology analysis. And in toxicology, what we want to specifically talk about is the blood alcohol analysis. Now, once again, in the forensic labs, in the Ministry of Interior labs, this analysis, or in many different hospitals as well, this analysis is very routinely carried out. And once again, as you can see, the hardware looks very similar to what we saw in case of USB 467. We have the headspace, we have the inlet. Once again, the inert T is looked at, or inert T is used. And then we have again two columns, two FIDs hardware arrangement. Once again, for the headspace, three options for the headspace, either 12 vial headspace or a 48 vials headspace, or the 111 vials headspace. 48 vials headspace, which number wise is 8697A headspace, is the latest model from Agilent, and it comes with all the latest modifications that one can offer or one can have. So it is the most recent headspace from the Agilent, and the best part of that latest 8697A series headspace is that the headspace and GC actually doesn't require the hub for the communication anymore. They are connected to each other directly without any hub, and so the communication actually is far better, and therefore the use is that much faster. So that headspace is available. Then we have the arrangement is exactly the same. So we have the headspace, the splitless inlet, the inner T going to two separate columns, and then we're doing the analysis. And once again, for the same reason, why do we have the two columns? Is because there might be possibility that we might be interested in looking at many more oxygenates, just not say, for example, the ethyl and methyl alcohol, but there might be some other compounds also that one might be interested in. And therefore, having these two columns, the blood alcohol 1 and the blood alcohol 2, these two columns actually will help us to do the separation better. And therefore, we'll be able to report all the oxygenates, all the alcohols and related compounds really well. The typical chromatogram, as you can see here, we have the BAC1 column and then the BAC2 column. And as you can see, the BAC1 column takes little longer. It takes around 4 minutes for the separation, but the BAC2 actually does all the analysis in less than 3 minutes. But you can see, if one is looking at the baseline separation of all the peaks, if one is looking at a very good separation of all the compounds, probably the BAC1 is a better column because it does much better separation of many different oxygenates. So the methanol, acetaldehyde, ethanol, isopropanol, tertiary butanol, propanol, and some other compounds. These are the typical oxygenates that one look for in the blood when we do the blood alcohol analysis. And as you can see, two columns, two FIDs once again offer the better possibility. The next analysis, the next segment that we are going to talk about the environmental analysis. Now, in environmental analysis, GC is used for many different analysis, and most of the times people actually use GC hooked up with the MS or the MSMS, because mostly in environmental analysis, we do the analysis of VOCs and SVOCs. Now, the typical SVOCs and VOCs analysis, we do it using GCMS. But the total petroleum hydrocarbon is again another analysis that many testing labs, many even the hydrocarbon or the HPI labs also actually do. And therefore, this application would be a very interesting application to look at. Here, we are not looking at a very standard 8890 series GC, although the 8890 series GC also is useful, but we are actually giving you another option. We are saying that please look at this another GC, which is Induvo 9000 series GC. And as you can see, this GC looks very different. I'm not sure if you have had a chance to look at this GC earlier, but this GC looks very different than a traditional GC. It's actually very compact, so the GC actually is only this much width-wise, and the depth-wise it is actually a little longer. But GC is very narrow, and so the overall space requirement on the table is very less. The GC has got a very flat column, as you can see here. It's not the typical column which is actually having the winding and therefore a bit of a depth. That's a typical column, what we all have used to seeing. This column actually is very flat. So it actually is a column that looks like maybe like, say, your compact disc that you might be putting inside your music system. But because column is actually very flat, the space required to put that column inside the oven, and therefore, or that oven actually becomes that much narrower. Because the oven becomes narrower, the heating of the column is very efficient. So you will be able to heat the column very fast, very quickly. Now, what is the advantage of that very fast, very quick heating? We actually can speed up the analysis really well. And therefore, earlier case where you might be taking, say, for example, 30 minutes to do the analysis, it is possible that that same analysis can be done with the same kind of resolution, okay, in less than 5 minutes, say, for example. The column, although the winding is different, the column make, the stationary phase, remains exactly the same. So earlier, if you were doing that analysis with your traditional column, you will get that same exact stationary phase quality with this new Induvo columns, and you actually will be able to do the analysis with that same quality, except for the fact that you will be able to run the analysis much more faster. So as you can see here, there is that special arrangement for the column, and therefore there is a special arrangement for the oven. There is a disposable guard chip that sits just immediately after your inlet. Now, what is the advantage of this guard chip? The column actually is the heart of your GC, right? The column is going to do the separation. So we want to make sure that column remains good for much longer time. How do we do that? We actually can control the junk part of the sample, and then if we can control its entry onto the column actually will remain clean for much longer time. How do we do that? We actually can trap the junk that might be present in our sample in this disposable easy, and you actually can do that using even a finger typed nuts. Or if one wants to use some tool to put the columns back in or remove the column from the GC, the tool actually is fixed on the GC door itself. All that you need is this one single tool to operate this complete GC. You don't need any other thing. So as you can see here, the disposable guard chip is available. The ferrule-free click and run column connections are available. No trim columns are available. Direct heating, as we just saw, direct heating of your column is possible. And all these things make your GC run really go very fast. And therefore, you would see that the earlier runtime, if it was for 30 minutes, we actually can squeeze that. We can make it faster, and we can actually do that same run in maybe in less than 5 minutes. Okay, so you see what different things are available with the Induvo GC that are not available with the typical GC that we are used to seeing. Inlet remains the same. It remains exactly the same. Nuts and ferrules are gone. We do not need nuts and ferrules. The guard chip comes in. The guard chip protects the actual analytical column. The typical column that we've been seeing on the earlier or the traditional GC looks like this. And anytime the column gets dirty, we actually cut the column. Okay, we cut the column. Every time we cut the column, the retention times changes, and therefore we are asked to do the recalibration. Of course, because the retention times are going to change. All that part, all that difficult part is actually taken care of in the new GC. So with the Induvo GC, what we have this column, which is actually having no possibility of cutting the column. Now, therefore, to keep the columns clean, we are using the guard chip. And the guard chip is just simple chip that we actually can install. And once it gets dirty, we can remove it, replace it with the next guard chip. And that's how we actually can manage the column really well. Because column will not go dirty, and that's our observation, because the guard chip do save the column. Because column doesn't go dirty, we are not going to cut the column that frequently. Because we are not going to cut the column that frequently, we don't really need to keep doing this calibration, recalibration process all over again. The method might ask us to do the recalibration again and again. If that is the case, we have to do the recalibration. But otherwise, just because we have cut the column, now the retention times have changed, now I need to do the recalibration. That part we actually can take really well. We can take care of that part really well if we have the Induvo GC. If we see the analysis, we are looking at this standard of C10 to C40. The entire analysis on Induvo is possible for us to finish in less than 2 minutes. Now, we can see the resolution is really good. The peak shape is also really good. The peaks are actually looking really, really sharp. You can see heptane is the solvent in which standard was prepared. And then C10 to C40 is what you are able to see. Separation has occurred, exceptionally well separation in less than 2 minutes. Now, this actually is really useful for the TPH analysis, is because I have seen the private testing labs where they want to do the TPH analysis. They tend to have many samples that they need to run in 1 day shift. If you're able to do your analysis this fast with this kind of separation quality, with this kind of resolution, you actually will be really able to do the analysis really fast, and you will be able to run many analysis in a 1 day shift. So you can see the standard run looks really well. Not only the standard run, but if you see the sample runs, they also look excellent. So you see these are our cutoffs. So C10 and C40 is what we are looking at as a range for our analysis. If you see the insets here, no, you actually will be able to see the retention time for C10 and the retention time for C40. So you see C10 and C40. Average retention time is 0.75 minute. Average retention time for C40 is 1.80. And then you will be able to see that standard deviation is very less. Relative standard deviation, therefore, is also very less. So the analysis of TPH, which otherwise actually takes quite a bit of a time, if you are using the Induvo GC, you will be able to run that analysis in less than 2 minutes, and you see the repeatability quality of the analysis. What you see here is an overlap of 10 chromatograms obtained from duplicate analysis of so and so soil sample. The inset chromatograms and the table show the retention time precision for the C10 and C40 marker compound. So you see C10 here, we see C40 here, or C40 here, C10 here, and this is how precise the data looks like. So you see we are able to do that very complicated analysis, reasonably complicated analysis, in less than 2 minutes. And this is the strength of the Induvo GC. It's possible because of the Induvo GC. So with this, I actually will stop and would once again like to say that although the HPI is a very traditional market where we have seen many labs using the GC, it's not the only place where the GC is useful. There are other sections, as we just saw the USP 467, so the residual solvents, pharma, food, frames analysis, toxicology, we saw the blood alcohol analysis, and then environmental section where we spoke about the total petroleum hydrocarbon analysis. So for these different techniques or for these different analysis as well, GC is very useful. So with this, I would like to stop and I'm available for the Q&A. Thank you.